Okay, this is 1988B free response, and what we have is a sample that's burned according to the equation, and it releases this much heat. And the first question is to calculate the molar heat of combustion. And students are getting confused about what is the difference between all these different types of heat. So we know heat has to be a delta H, and we're looking for combustion heat, and the combustion is for this reaction. That's a combustion reaction. So basically we're trying to find what is the delta H for this reaction. We have some H data, and so we want to do products minus reactants, moles times products minus reactants, but the problem is we actually don't know one of the values. So we can't do that. We have to use our other data, which is the 2 grams and that many kilojoules. And we want units of kilojoules per mole. So we have 64.98 kilojoules, and we need moles, but we have grams, so we have to go from 2 grams and the mass of the phenol. Sorry, I've got to find it. 2 grams, and the mass of the phenol is 94, and that's for 1 mole. And whatever number you get here, you're going to divide that number. You're going to put that number under here, and that's going to be your moles, and you're going to get your kilojoules per mole. I don't have my calculator with me, so I can't do it, but it's negative 3058, and here we had 4 sig figs, so we're keeping 4 sig figs, kilojoules per mole. Now we have the heat of formation. Now what is the heat of formation? It is the energy needed to form this, or energy released from forming this, from its elements. So it would be carbon plus hydrogen plus oxygen, making C6H5OH. But really, we don't need these values or the values of the bond energies. We're going to use the values in this table. So we'll do the H that we just found, whoops, way up here, the H that we just found, this value, delta H, is equal to the H's of the products, so the H2O, 3 times the H2O, plus 6 times the CO2, minus the reactants. And O2, of course, is 0, but it's in the table too. So, when you do that, you can actually just look at the key. That's the calculation that they did, and we end up with negative 161 kilojoules. Then we need to calculate the value of G. So we have H for the reaction. We want to use this one because we're talking about G for the combustion reaction, not for the formation reaction. So we have we have H, and we can find S because we can do products, entropy of the products minus entropy of the reactants. And just remember to do the number of moles of each one. So you're going to calculate S, and you'll get negative 87.67 joules. And then we know going home to supper. And we have 25 degrees Celsius, so 298 here. Negative 87.67 is in joules, so you have to change one of them. Normally we change the joules one, so we're going to divide by 1,000 to get kilojoules. And then kilojoules per Kelvin, and Kelvin's here, Kelvin's goes away. And we have delta H, which we just did, negative 3058. We're going to use those values to find G, and G is going to be negative 3032 kilojoules. So, highly spontaneous. And then, problem D is a doozy. But I don't like the way the key does it. We have a volume is 10 liters. And we have a temperature, which is 110 plus 273 would be the total temperature. And then we need to find the moles, and we also need and that's going to allow us to find the pressure, which is our unknown. So I'm actually going to cut this video and do number D on a different podcast because it's getting too long.